Morning all, this is D. Jagan from SRIT. I am studying in EC department. Today I am going to tell about the Taylor's theorem in the subject of linear algebra and calculus. Introduction to sign expansion. We are already aware of that the sine, cos, tan and cosecant, secant and cot. These are the primary trigonometric functions. The sine function is a fundamental trigonometric function. Expanding this sine function around a point helps in approximating its values. We will focus on expansion around sine x is equals to pi by 4. Introduction to Taylor's concept. The Taylor series concept. It is a series. We already know series. F of x is equals to sigma y n is equals to 0 infinity up to infinity f to the power of n into a by n factorial into x minus a of n factorial. The Taylor series allows us to express functions as infinite sums. It uses derivatives of a function at a specific point for expansion. We will derive the Taylor series for sin x centered at pi by 4. The Taylor series form. The Taylor series of a function f of x at a is given by f of x is equal to f of a plus f dash a into x minus a plus x minus a whole square by 2 factorial into f double dash of a plus and so on. We will substitute f of x is equal to sin x and a is equal to pi by 4. This will yield the coefficients needed for our expansion. In the double coefficients is equals to f of x comma y is equals to f of a comma b plus by 1 factorial of x minus a into f of f dash of a comma b plus y minus b f dash of a comma b. Calculating sine pi by 4 values. As we know the trigonometric functions, first we calculate the function value at the center. Sine pi by 4 is equal to 1 by square root of root 2. This value is critical for first term of our expansion. Next, we need to find the derivatives of sin x. Derivatives of sin x. The first derivative is cos x and second is minus x. Continuing this, we find higher derivative, the third derivatives and the fourth derivatives. Here are some examples. Given f comma f of x is equal to e power x sin y, if fx is equal to e power x sin y, if double x is equal to e power x sin y, if triple x is equal to e power x sin y, if y is equal to e power x cos y, if double y is equal to e power x minus sin y, if triple y is equal to minus e power x cos y, if xy is equal to e power x cos y, if double xy is equal to e power x cos y, if x double y is equal to minus e power of x sin y. Evaluating derivatives of pi by 4. We evaluate the first derivative and the second derivative as the pattern goes on. This pattern continues for all higher derivatives. Fx of 0, 0 is equal to e power of 0 sin 0 is equal to 0. F of double x of 0, 0 is equal to e power of 0 sin 0 is equal to 0. If triple x is equal to 0, fy is equal to 1, f double y is equal to minus 1, if xy is equal to 1, f double xy is equal to 1, fx double y is equal to 0. Constructing the series. Using the derivatives, we construct the series expansion. The values of these sine y, we have to substitute these values in the Taylor series formula. Using the derivative, we construct the series expansion. Each term corresponds to a specific derivative evaluated at the series. The series will alternate in sign and decrease values. F of x comma y is equal to 0 plus 1 into x minus a into 0 plus y minus 0 into 1 plus 1 by 2 of x minus 0 whole square into 0 plus 2 into x minus 1 x minus 0 y minus 0 into 1 plus y minus 0 whole square into 0 plus 1 by 6 x minus 0 whole cube into 0 plus 3 of x minus 0 whole square y minus 0 into 1 plus 3 into x minus 0 into y minus 0 whole square into 0 plus y minus 0 whole cube. At last, we have the value of e power of x into sin y is equal to y plus xy plus 1 by 2 into x square y minus 1 by 6 y cube. Final series expansion. The final expansion of sin x and around pi by 4 is e power of x into sin y is equal to y plus xy plus x square y by 2 minus y cube by 6. This series can be truncated for approximation. The more terms included, the better approximation. Applications of series expansion. The series expansion is useful in numerical methods for computing e power of x into sin y. It also aids in simplifying complex trigonometric calculations. Engineers and scientists often rely on Taylor series for modeling periodic functions. Example calculations. To approximate sin of 1, we can substitute x is equal to 1. Using our expansion, we calculate up to a few terms for a quick estimate. Comparing the results with the calculator can show the accuracy of our approximation. Limitations of the expansion. The Taylor series is valid only within a certain radius of convergence. For values of x far from pi by 2, the approximation may degrade. Understanding their limitations helps in better application of the series. Hence, we conclude that it enables easier calculations and deeper insights into trigonometric functions. Mastery of Taylor series opens doors to advanced mathematical applications. Thank you for giving me this opportunity. Have a nice day.